In April 2026, a cruise ship carrying roughly 150 passengers and crew set sail from the port of Ushuaia, Argentina, charting a course for the remote islands of the South Atlantic. 5 days into the trip, a 70-year-old passenger develops a fever and mild diarrhea. Within hours, his condition rapidly deteriorates. His lungs flood with fluid, making it impossible for him to breathe. By April 11th, he is dead. Nobody on board knows why. When the ship docks briefly, his wife leaves with his body, only to collapse at an airport a few days later and die. Back on the still-sailing ship, other passengers begin falling ill with the exact same symptoms. Panic sets in among the crew and the remaining healthy passengers. As news of the deaths leaks out, the ship is effectively turned into a floating quarantine zone, stranded in the ocean as port after port refuses to let them dock out of fear. A sealed vessel with a rapidly spreading, unidentified pathogen is a specific kind of psychological terror. For a world still scarred by recent lockdowns, watching a ghost ship wander the seas with a lethal mystery illness feels like our worst collective nightmare playing out in real time. When health officials finally manage to coordinate testing, the diagnosis is hantavirus. This pathogen first came to light in the 1950s, when it struck thousands of American soldiers fighting during the Korean War. Despite knowing about the virus for over 70 years, modern medicine lacks a single FDA or WHO-approved vaccine or proven antiviral cure. If you are infected, doctors can only provide supportive care, leaving your immune system to fight a virus that up to 50% of its victims. While hantavirus usually infects humans via rodents, the specific strain on this ship is the Andes virus. This variant has evolved the rare ability to spread directly from person to person. A 50% mortality rate, no medical cure, and the ability to jump between human hosts. These three variables create the specific conditions required for a global health catastrophe. Hantavirus belongs to a broad family of rodent-borne pathogens that exist naturally within animal populations. The ecological drivers behind how the virus reaches humans were identified following a 1993 outbreak in the United States. After several young, healthy members of the Navajo Nation died, investigators began tracing a specific environmental pattern. It starts with an El Niño event, which brings unusually heavy rainfall to the region. This extra water leads to a bumper crop of pine nuts, creating a massive surplus of food in the wilderness. Local rodent populations gorge themselves on this harvest, causing their numbers to grow at an explosive, exponential rate. As thousands of extra mice compete for territory, they spill out of the wilderness and seek shelter inside human homes. The resulting proximity increases the risk of humans inhaling infectious particles from rodent droppings, leading to spillover. These outbreaks are not random biological attacks. They are predictable ecological reactions to specific shifts in the global climate. While spillover typically requires direct rodent contact, a 1996 outbreak in southern Argentina proved the Andes strain could jump directly between human hosts. The Dutch couple on the cruise ship contracted this specific strain right before boarding. During a birdwatching tour in Ushuaia, they visited a landfill heavily infested with rodents. Because they returned to the ship immediately after being exposed, they brought a rare human-to-human strain directly into a high-density enclosed environment. The geography of their shore excursion and the architecture of the ship created a rare incubator for this mutated pathogen to move through the passenger manifest. Despite this lethal capability, hantavirus faces severe biological roadblocks that prevent it from becoming the next COVID-19. Unlike a flu that can fill a room through the air, hantavirus requires prolonged, direct contact with bodily fluids to transfer. You essentially have to be in the immediate physical space of an infected person to catch it. Furthermore, the transmission window is microscopic. While a COVID patient might be contagious for 2 weeks, an Andes virus carrier is generally only contagious for a single day at the very beginning of the illness. These biological limitations act as a bottleneck, crushing the pathogen's ability to trigger a sweeping global pandemic. The cruise ship story eventually reached a resolution when it was allowed to dock in the Canary Islands. The passengers were evacuated, isolated, and provided with medical care. Because of that 24-hour transmission window, the virus naturally burns itself out once the initial circle of close contacts is physically isolated. The ongoing threat is tied directly to these climate patterns. As El Niño events drive up rodent populations, the baseline risk of humans encountering the virus rises. Managing that risk requires structural defenses. This means sealing homes to exclude mice, safely disposing of waste, and wearing N95 masks when cleaning out closed, potentially contaminated spaces. While we lack a biological cure, we can neutralize the threat by recognizing its environmental triggers and biological limits. Understanding how this virus operates transforms it from an inescapable terror into a manageable hazard.